Hello everyone, in this video I will be walking through my Excel analysis of the logistics deliveries dataset. I have structured my work into multiple tabs: the raw data, the pivot dashboards, correlations analysis, and regression modeling. Let's go through each one step by step. In datasheet, this first sheet is where I imported and prepared the raw delivery records. I converted the dataset into an Excel table called truck record. And I will show you the truck record guys as well. Yeah, you can see on my screen as well guys. So that I could use structured references. This makes the formulas and pivots more consistent and easier to manage. The dataset includes key fields like distance, fuel cost, toll charges, other costs, and the final total cost for each delivery. And I also added two new entries on the last right side: predicted total cost and residuals. Table 2 pivots, dashboard and charts. Next, I created multiple pivots tables and charts to summarize delivery patterns. First one is delivery volume per destination. This shows the number of deliveries across different cities. Adelaide and Sydney stands out with the higher volumes while Canberra shows the lowest. The second one is yearly delivery pattern. This pie chart compares deliveries between 2024 and 2025. The split is fairly even with the slightly majority in 2024. The third one is mean delivery cost across truck types. Here we can compare the average cost. Heavy duty trucks are clearly the most expensive, while flatbed and refrigerated trucks are on the lower side. The fourth one is route distance matrix heat map. This pivot heat map compares distance travels across cities and truck types. Canberra stands out for longer routes, whereas Hobart and Brisbane have relatively shorter distance. I also added slicers for dispatch, year, destination, truck type, cargo type, and delivery status. These slicers make the dashboard interactive so I can filter all the pivots and charts simultaneously. Table 3 is correlation. On this sheet, I explored how different variables are related to the final cost. I calculated the correlation matrix, which shows strong positive correlations between distance, fuel cost, and the total cost. Toll charges and other costs, however, show very weak relationships. To make this more interactive, I also added the correlation boxes. Number one is distance versus total cost. Number two, fuel cost versus total cost. Number three is toll charges versus total cost. And finally, I created a scatter chart of versus distance. This chart makes it clear as distance increase. Fuel cost also rise, which directly drives the total delivery cost. Table 4 is regression. The regression tab takes the analysis further. I ran a multiple regressions using distance, fuel cost, toll charges, and other costs as predictors of total cost. The R squared value was extremely high, which confirms that the model explains almost all of the variations in cost. I then created two spotting charts. The first compares actual final cost versus predicted final cost. The point line up very closely and along the diagonal, showing the model's accuracy. The second is a residual histogram, which shows that the residual errors are entered close to zero. This indicates that the model predictions are reliable and unbiased. Closing. In summary, the distance and fuel costs are the strongest drivers of the delivery expenses. Heavy duty trucks are costlier, and long destinations like Canberra contribute significantly to higher costs. Using these insights, fleet managers can optimize routes, assign trucks more efficiently, and reduce overall expenses. That includes my walkthrough of the analysis. Thank you.